All right, so we're beginning a new unit today. So in Unit 8, the topic for this unit is vectors. So in this first section, 8-1, okay, we're just talking about the basics of what a vector is and really how to write its component form and to find its magnitude. All right, so let's talk about a vector. What is it? Well, a vector is really just a directed line segment. All right, it's got a starting point, it's got a direction, and it has a magnitude, which is its length. Okay, and so when we're talking about vectors here, so if you've got one that starts at the origin, if that's its initial point, okay, then you could say that that vector is in standard position. And the component form of the vector, it kind of looks like this. Here's the notation. Okay, if it's in standard position where its initial point is at the origin, then the terminal point has these coordinates, v1, v2, and then you can write the component form of that vector as, and notice the symbol for the component form. It's not a bracket or a parenthesis. Okay, it's almost like a sideways V, you could think of it of. And then so the component form for that vector in standard position would just be the coordinates of its terminal point v1 and v2. Okay, so v1, v2 are considered the components of v. And when you have a vector in component form, this gives you the direction. Because remember, a vector has direction and magnitude. This gives you the direction. So this gives you the horizontal direction, and then this one gives you the vertical direction because it's off of the x and the y coordinate. And we're talking about horizontal and vertical direction from the initial point, okay, not the origin, okay, from the initial point. Now, if it's in standard position, the initial point is the origin. But just remember, this component form gives you the direction, how many left, right, how many up, down, from the initial point. And remember, the initial point doesn't always have to be the origin. Okay. Another thing, if the initial point and the terminal point lie at the origin, that's the 0 vector. All right. And so again, for the component form, all right, if the initial point is P1, P2, and the terminal point is Q1, Q2, all right, then the component form is found by subtracting the x of the terminal point from the x of the initial point, and the y of the terminal point minus the y of the initial point, and then that would give you your component form. Because remember, the component form is how far vertical and horizontal direction from the initial point, and then that's how you can get those coordinates. Now let's talk about the magnitude. Okay, the magnitude is the length of the vector, and notice the notation. It's kind of like double vertical bars there to represent magnitude of a vector. And this part should look very familiar. This is pretty much just the distance formula. So the distance between the initial point and the terminal point, that is the length of the vector, which is the magnitude. So it is the same distance formula pretty much. Okay? Or if you've already got it in component form, then it's just the square root of v1 squared plus v2 squared if you've already got it in component form. Okay, because component form is the change in x's and the change in y's. All right, so there you go. Okay, so a couple of notes down here. If the magnitude is 1, then v is the unit vector. If the magnitude is 0, okay, it can only be 0 if and only if the v is the 0 vector. Right? Okay, so the only way the length of the vector can be 0 is if it is the 0 vector. Now, when we're talking about equal vectors, two vectors are equal if and only if the u1 equals the v1 and the u2 equals the u2. So only if the corresponding components are equal, that's the only way that the vectors can be equal, right? And so, like for example, if one vector has a initial point of 0, 0 and a terminal point of 3, 2, right? From 0 to 3, that's a 3, right? From 0 to 2, that's a length of 2, so the component is 3, 2. So that would be the component form of that vector, all right? And let's say I've got a vector whose initial point is 1, 2, and terminal point is 4, 4. Well, from 1 to 4, all right, so that's a horizontal movement of 3, and from 2 to 4 is a vertical movement of 2. It's the same components, right? So since each part of the component is the same, right, the corresponding components are the same, then that means that those two vectors are equal. Now, they're in different positions, but they're equal. So basically, if the magnitude of the two vectors is the same, then the vectors would be considered equal. All right? So if they're the same length, they're considered equal regardless of what position they're turned in. It's almost like how congruent figures were in geometry. All right? Let's see. So what's the main thing that we have to make sure we're able to do by the end of this lesson? Well, we need to be able to write the component form of the vector and then also find its magnitude. So we want to find the component form and the magnitude of this vector that has an initial point at 4, -7, and a terminal point, okay, at 1, 5. Okay. Now, make sure you don't get the initial and terminal points mixed up, because that would make a difference in the component form as far as the direction is concerned. So be careful with that. All right, so for the component form, make sure you're using the right symbol now when you're looking at this. So the component form for the vector. So the first piece of the component form is going to be the horizontal distance as far as left as right is concerned. So how do I get it? Again, I can look back here and see that to get the component form, I need to subtract the x-coordinate of the initial, the terminal point minus the x-coordinate of the initial point. And so when I do that, I'm going to have terminal point -1 minus initial point -1 minus 4. That's -5. All right. Or you could just say from 4 to -1, that's going down by 5. That's probably the quickest way to get it. Then, of course, with the y-coordinates, it goes from -7 to 5. That's up by 12. And then there is your component form. There's your component form. So you can write out the full, this entire thing if you wanted to, and come up with it. Or you can just say, okay, from 4 to -1, down by 5. From -7 to 5, up by 12. That's the component. Okay, so now how would I take this and find the magnitude? So in order to find the magnitude of this thing, again, make sure you're using the correct notation. Notation is important here. And so the double bars indicate the magnitude. And so how do we find the magnitude? All right, it's just going to be this part squared, -5 squared plus this piece squared, 12 squared, and then the square root of that. And so that's going to be equal to the square root of, so negative and negative makes it positive, so that's a good thing about that. It'll positive itself out because we're squaring it. So that's going to be 25 plus 144, which is square root of 169, which is going to be equal to 13. 13 is the magnitude of this vector. 13 is the magnitude of this vector. Okay. One more example for us to look at here. This time they just give us the 2 points and instead of the graph to look at. Okay, same idea. They tell us A is the initial point, B is the terminal point. Because like I say, that does make a difference as far as the component form is concerned. So we need to know which is the initial point and which is the terminal point. So for the component form here, let's see what we got. So from 2 to -6, I would say that's down by 8. Now, if you have trouble finding how much up and down it is just by doing it in your head, then please make sure you go back to this full formula so that you can get the answer right. So from 2 to, now I'm just kind of showing you a shortcut. From 2 to -6, that's down by 8. So that's that component, -8. The other component, from -7 to 9, that's going to be up by 16. So there's your other component. So now that I've got the component form, then I can use that to now find the magnitude, which is going to be square root of -8 squared plus 16 squared, which is going to be equal to the square root of 64 plus, that is 256, and that's equal to the square root of 320. All right. which is equal to, so now I need to write this, my answer choices are actually going to be in exact form, not decimal, so I can't just throw this into the calculator and make a decimal out of it. I want the exact answer. So what I'm going to do is I'm going to have to break this down into its prime components. And it turns out that this thing breaks down to 2 times 2 times 2 times 2 times 2 times 2 times 5. So that would be 2 to the 6th power times 5. All right, 2 to the 6th power times 5. Okay, so what that means is I can pull out pairs of 2s. So if I've got 6 2's under here, I can pull out 3 pairs of 2's, which is 2 times 2 times 2, which is 8. So that'll be 8. And square root of 5 is trapped underneath there with no pair to escape it. Okay, so it may take a little thought of how to break this down into its prime factors. I know the calculators that we use in class, there's a button that does it for you. You can probably find something online if you just Google prime factorization or factoring a number or whatever. There's probably something online that you can use to plug that in, and it would give you this, maybe to save time. And then you can just pull out the pairs and then multiply them together. 2 times 2 times 2, because there's 3 pairs, 8, and then square root of 5. All right? So there you go. That's it.